So that's really reporting on activities we've done over the last 3 years in an EU-funded project, ENDEAVOUR, that was in collaboration with DECIX, Germany, and then a few other institutions, mostly universities, within a small EU project. So what was the point of that project? Well, basically abusing the opportunity of IXPs that basically was still new at the time, or the research community discovered recently, or not that a long time ago, oh, well, yeah, there are lots of IXPs, they exist there. They still don't really care or understand what they do or how important they are, but it's coming there. So why IXPs? Well, because they're really a key player nowadays in terms of amount of traffic. We don't really know how much, but given the number of IXPs out there, like according to PeeringDB at the moment, however trustable PeeringDB is, it's like 600 plus IXPs at like 300 plus locations. They've got lots of members, or a few of them are really, really large. I mean, if you think in Europe, AMSEX, Lynx, DECIX, and there are plenty of others. So they're quite a big player, and the reason why they're interesting is not just they are big, or but really more that if you want to think about, okay, is SDN really worth it? So SDN, it's basically open flow. Is it really worth it? Well, they are probably a good place because you can have a lot of impact if anything happens. If you buy SDN, or not buy, but actually think that the SDN features might be interesting, but then basically you may have an impact using infrastructures that are relatively simple compared to trying to deploy that inside a large ISP, which would probably be a pain in the butt. So what's the problem really, or what is it like, okay, you want to do SDN, but like, what are the problems or the specifics that you may want to address with SDN? Well, the usual inter-domain things. Peerings are slow to establish. Well, yeah, fair enough, we know that, but that's nothing fancy. Constraints in the sense that doing forwarding is destination-based. So, I mean, like we just mentioned here, prefix validation, or when things go wrong on the control plane nowadays, well, we don't really know what's going on. So we don't have a good view of what's happening. The forwarding decisions we make nowadays is kind of limited, and it's reachability-based. So you can't do much more. I'm not saying that you want to do much more, but if you want it, that would be tricky. So today's interdomain really is kind of myopic. So yeah, we have BGP tables and we can check and trace route and try to troubleshoot or see what's happening to the end-to-end path. But most of the time, we don't really know what's going on. And even when it goes about our neighbors, can we trust them? Well, in terms of security, even on neighbors, we may not be able to influence them or be sure, okay, are the routes I'm receiving legit, or should I black hole or filter some of these? So it's a bit tricky nowadays. So, well, what can SDN do for you? Yeah, in theory, a lot of things. You may not care about them or want them, but for example, for monitoring purposes, you can do packet header matching that could be quite interesting compared to what you can do today in today's switch or others, which is not much. Basically, it's going to be NetFlow, SFlow, and you export kind of everything or nothing, or a very limited subset, and that costs you a lot of storage. While with SDN, in principle, you've got the advantage that you match something, and the matching is the forwarding. So it's the same thing. You can target a specific subset of destination and do only SDN for them, whether that's for monitoring or control other purposes. So the other interesting part of SDN, OpenFlow, which was something that's more interesting for the research community, is more like it gives you a programmatic view of the network. So from a management perspective, you've got a centralized or distributed controller that is your management plane that then controls the logic and the rules so that the control plane and the data plane are kind of congruent, or they are doing a bit more the same thing, while nowadays we have, well, routing protocol, logic, and magic, and then what's happening in the forwarding might be quite a different story. So that gives you a more high-level view of what you want to do in the network and how you want to implement it, and that will be directly implemented in terms of packet forwarding, packet handling. So that's the theory. So what can really SDN do for SDN, for interdomain, but in the context of IXPs, since this is a project where DECIX was the main stakeholder. So there were two types of things that DECIX was interested in evaluating or trying to have a clue. If we were to do that with SDN or using SDN as a supporting mechanism, could we do that? So the first type, the IXP operators use case. So if you are an IXP, you operate a network, you've got lots of members, you've got a lot of peerings to manage. And peerings, not only layer 3 or the BGP endpoints, but also the layer 2 and MAC broadcasts issues, and that's kind of a pain for large IXPs. So with SDN, you could simplify the management in principle. IXPs are relatively simple, so you can say, well, why do you need to simplify something that's already simple? Well, or at least you can build a management plane that has augmented capabilities without bloating it with routing protocols. So one of the reasons why DECIX came to us and were interested in that type of project is actually they were replacing the layer 2, and they were considering either using Trail or maybe SDN, or thinking, well, if we use SDN, how would that work? And that project was kind of a spin-off what-if scenario, or can we build software that could actually deliver this? You can, of course, do monitoring and mention that, because with SDN, forwarding and monitoring will basically be more or less the same. It's just the action once you match the packet that will trigger, do I export that record or not? And then you could build services on top, because SDN is kind of a programmatic, logical view of the network. You could actually build new services on top of the existing management plane in a, let's say, more convenient, easier way than by introducing a new routing protocols or features on all your routers, because it's not dependent on the features of the routers as long as they can do SDN. That's on the IXP operator side. Now, there is what's in there for IXP members or customers, depending on how politically you want to see them. Well, there is the security issue. I mean, there is a company out there that is doing DDoS detection and mitigation. Well, obviously, as an IXP member, it would be nice if actually when there is unwanted traffic, it can be filtered as early as possible. And that means not just at your own side of the peerings, but a bit deeper, because the earlier in the network you filter that, the more effective the DDoS mitigation is going to be. The more upstream is better. So you could think of a use case where basically the IXP is helping you basically filter traffic when you realize there is a DDoS going on. You could do traffic engineering as well. If you are a large CDN, you've got a lot of peerings, you may want to do fine-grained traffic engineering across them, basically, and have support from the IXPs to do that. Or you could do silly things like application layer peerings, or more dynamic or different types of granularities at which you would do peering that you would do today. That's hypothetical. So that's the example of the use case where you would have a victim member that basically will ask through a SDN API, can you please block that traffic because I think it's a DDoS? And then the IXP might actually help you filter that within its fabric at the ingress ports, rather than when it's too late and hits you or in the middle. So what did we do actually in this project? So that's really what I'm reporting on, is basically an architecture. So we extended the software stack of IXP, a typical IXP. Well, I'm not too sure DECIX is typical, but here it's relatively high level, so it's not related to DECIX. So you've got the SDN fabric. Imagine this is an IXP, and that's the software that's relevant for the IXP operator. Then you basically have the usual proxy to handle layer 2, the member information base, and then there will be the peering management. And basically what we would do here with this software stack is really replace the management plane or augment the management plane with this fabric manager, which does two main things. First, manage routing policies and the peering side between the members within the IXP. That's the edge ISDX. So it's trying to basically enable people to express routing policies or peering related traffic handling at a different granularity compared to what you would do today. Today you would establish a BGP session and then traffic would come up and that's it. While here, basically you will have SDN that will basically tag packets and manage the slices, so you kind of virtualize automatically what the members do at their convenience, let's say. So that then the core part will, in our case, we replace the layer 2, so it replaced the layer 2 that would run within decades, and it will use something similar. You'll see at the next session there is a tutorial on segment routing, something similar to segment routing that is basically SDN based in terms of hop-by-hop forwarding within the core of the IXP. And then we've got also a monitoring platform, but I'm not going to mention it. I'm going to mention it later in the talk at the end. So what does that mean in terms of what the packet sees in terms of the software stacks? Well, basically at the edge, where most of the things really happen, you've got obviously the monitoring that happens, which is the same as the forwarding, where packets get monitored or tagged. Then they will be tagged by the ISDX side of the software that will basically handle, well, given that I received this packet from this ingress, depending on the routing policies and the peerings in place, what's the egress point or the set of egress points that should actually be used into the networks. Think of MPLS tunnels, basically, MPLS tagging tunnels at the ingress, so that the egress is already done by then. And then underneath, once you enter the fabric of the IXP, all the layer 2 and the hop-by-hop forwarding of the actual packets, which will be layer 2 then forwarding, will be handled by this umbrella part of the software track that runs underneath. Then in the core and at the edge, actually it's simpler because it's basically, there is always the monitoring running, which is the same as the forwarding in the case of SDN. And then the hop-by-hop forwarding, which is, you can think of segment routing within the IXP fabric that will basically bring the packet to the egress point until that point, and at the egress, well, the MPLS stack is removed, and then the forwarding is basically carried over. It leaves the IXP. So, oh, that was not the right version of the slides. I was planning on skipping that one. So, what's the next step, actually? So, the reason why I come here is not do advertising only, but it's more calling for help or potentially, because we didn't really deliver a proper monitoring stack within the ENDEAVOUR platform. We just didn't have time. So we had to concentrate and focus on the control plane, let's say, aspect, the management plane of the IXP to deliver something substantial enough. And then we left the monitoring for the next step, and the next step, I'm a researcher, I'm a professor, so you know the core is getting research grants, money, so there is always a next project, and that's the next project. So it's not an EU project, it's an EPSOC-funded project that starts next January, and this one is actually in collaboration with Links, somebody else, not DETIX, because it's a UK project, and two main university partners, that's ourselves, Queen Mary, and the University of Cambridge, and they are other partners such as Géant, Corsa, Cisco, and a few others. So what's the goal there is actually build, hopefully, or assess whether it's possible to build a scalable SDN-based, or that relies on the SDN primitives capabilities, monitoring infrastructure, so something that we should have done in the previous project, but we didn't have time. The goal is to enable reactive traffic engineering, so to bring a feedback loop into the network so that you do monitoring, you see something, and then you want to react to it. Like DDoS mitigation, for example, that's the perfect example of that. So that's our goal, and one of the steps needed is, well, we want to see how it's going to happen in real life, so we need to have a real autonomous system. So we'll have an experimental autonomous system where some of our software will run to emulate, basically, as if it was in real life, what would happen with this reactive loop, and learn actually on the way as we build the prototype to see, okay, how much monitoring can we handle, how fast can we react, what type of SDN API do we need to basically enable visibility in some issues like DDoS or maybe others for more simple like load balancing and other traffic engineering type of use cases. What do we need, or how do we evolve something that will work and be good enough to be actually used within an IXP? So that's it. Thank you. So it's a call for peerings. If you're interested in peering with us, or not interested but interested in the space, I'm happy to talk to you later on, and I'll be happy to take questions. Thank you very much.
Steve, thank you. We have time for questions. Are there any questions? Yes, here in the front. Who's running with the mic? You're running with a mic.
I'm running with the mic. Got it.
Hello, Craig Gallen, OpenNMS. How would the SDN-enabled measurements work alongside other measurement technologies such as SNMP or traditional ways of managing your network?
They would actually complement it. It's a very good question. So basically the core, I skipped the monitoring slide. The core of the monitoring would be a mixture of software and hardware. So you know you can't expect having SDN deployed everywhere in the network, or even if you expect it, well, it doesn't really matter. It might not be used. So it will always be a matter of how much visibility do you need, and basically there will be the SDN capabilities that are available, which will be zero at the beginning, or slowly go up depending on who we pair with. And then that means you need to complement with a container virtual machine type of solutions that will be running inside those networks to do some level of monitoring. How much, that depends on what's available and where you can actually run things, or whether you can actually run that on some of the available SDN switches that will be available nowadays. So it's going to be a hybrid mixed approach, and really, indeed, the tricky bit is how much visibility, or where do you need to deploy? Well, that's one of the open questions. How much visibility do you need in terms of measurements to actually be able to achieve something? And that's kind of tricky, because at the moment we don't really know. Even for DDoS detection, we just throw as much data or monitoring as possible, and then we're pretty like, okay, we see something, so, but we don't even know what subset we're actually catching. So yeah, that's the point. It's asking the question, is it even worth it actually?
Have you got a question?
Hi, I think it's really interesting. I'm aware of a couple of other EPSRC funded projects, Toucan and Initiate.
Yep.
I guess you know of those. Can you just very briefly say what the key differentiator is between what you're doing and what they're doing? I think
Here,
at least one of them is an SDS exchange, SDN exchange.
Here the focus is really the monitoring plane. So to understand at what granularity and how to build something like a, let's call it a monitoring overlay that will basically be good enough for specific use cases. And we have a list of use cases. DDoS detection is one of them. Traffic engineering is another. And so depending on that, it's looking really at the dependency between how much monitoring using a SDN API, and then how would the system scale just from a pure monitoring perspective to then be able to forward back. But we're not even trying to really close the loop in the sense that we don't expect to have a full working loop, but more be able to assess the reactiveness, or how much of reactiveness can you really do at all.
Okay. If there are no further questions, thank you very much, Steve. And ask our next speaker, Diego, to come to the stage.